into my intersection array and I will move forward. Next, 2. Are you here? Yes, I am here. So I'll take this 2. The moment I take this 2, I will mark it as visitor. I'll say this 2 has been taken by someone. This 2 has been taken by someone. Fine. We have 1, 2 who found its corresponding 2 in the other array. Now I'll move ahead. When I move ahead, I have a 2. And I'll see for a 2. I see a 2, but it's taken. Now I see a 3. So since it's a sorted array, I'm sure that beyond this there will be no 2. So I stop. I'll be like, I did not find. Next 3. Let's start 2. So if I do not find a 1, I start with the first element in the set, which will be marked as 0, 0, 0, 0, 0, which means they haven't been used. They haven't been used as of now. And now what I'll do is, I'll start with the first element in the first array. You can also start with the first element in the second array as well. But I'll start with the first element in the first array. And I'll say 1. Are you here? Are you here? Are you here? I'll just go through the entire B array and I will not find a 1. So if I do not find a 1, I will end up not taking this into my intersection array and I will move forward. Next, 2. Are you here? Yes, I'm here. So I'll take this 2. The moment I take this 2, I will mark it as visitor. I'll say this 2 has been taken by someone. This 2 has been taken by someone. Fine. We have 1, 2 who found its corresponding 2 in the other array. Now I'll move ahead. When I move ahead, I have a 2. And I'll see for a 2. I see a 2, but it's taken. Now I see a 3. So since it's a sorted array, I'm sure that beyond this there will be no 2. So I stop. I'll be like, I did not find. Next 3. Let's check. 2, no. 3, yes. Let's take 3. And at the same time say, you are taken. Let's go ahead. 3. Again, 2. Again 2. No, not equal to 3. 3, yes, equivalent. But taken. This guy's already committed. So I'll not take him. Next. Oh, he's not committed. And that's 3. So let's take this 3. And mark it as 1. Next, 4. Now when we have 4, do we have 4? No. Do we need to check for the next? No, it's a sorted array. So if 5, like till 5 you did not get it, beyond that everything will be greater than 5. So no need to check it. Next, 5. 5 you'll get it here. So you'll take 5 and you'll mark it. 6 you'll get it here. So you'll take it and mark it. And the iteration is over. Once the iteration is over, you will have your answer array. Yes, you will have your answer array. And once you have your answer array, that will be the brute force method. Got it? So if I have to write the pseudocode, what I'll do is, I will say n1 is the size of the A array, n2 is the size of the B array. And I'll probably keep a visited of size n2. And I'll mark every one of them as 0. Once I've done this, I will try picking up one element from the first array always. And for that one element, remember we have an answer intersection which we have to fill. For that one element, I will go through J and I'll go through the second array. Now what am I doing? I'm saying, okay, I is 0, which means I is standing here and I'm moving across the entire array. That is what I'm doing, right? So I will be like, okay, if array of I is equal to array of bj, if it is, that means for this A of I, we find a corresponding in the B array. And if we find it, we can take it. But wait, has it been taken previously? And this is where the visited array will tell me the visited of the jth index. So this is the indexing of the jth index. Are you not taken? Oh, you're not taken. Perfect. Please come to our answer. So this will be the corresponding added. So I'll say visited of j has been taken. So please mark it. And you can break out. There's no need to do any further. You can break out. Once you have done this, perfect. And what's the other thing? If this condition is false, we just move ahead. But be sure if at any moment if at any moment the array of b and j is greater than array of A of I, we say, okay, we've exceeded. You will never find, even if you go ahead. So this will kind of truncate this loop. Just in case you are getting someone greater, there's no point in going forward. There's no point in looping. So you stop and you can just stop it here. So for every I, you will loop through the entire array B and you'll try to find someone same and which is not taken. If it is not, then you kind of add it to your answer and mark it as taken and you break out. So you keep on doing for every I and at the end of the day, you will have your answer array. So if I have to determine the time complexity of this brute force approach, what will it be? Obviously 2 loops running. So that's an N1 cross N2 at the worst case if the break and all these things never happen. At the worst case, N1 cross N2. And what is the space complexity? Obviously the space complexity is big O of N2 in this case. Imagine you apply a visited array for this. You can do the reverse as well, where you have a visited for this and you iterate for this and you check for the corresponding in the other array. You can do how you wish. So that is okay. So we can say that in the order in which we apply the algorithm, the space complexity might change. So logically, it will make sense to have the algorithm in such a way that for the smaller array, we have the visited array, so that the space complexity is minimum. But But it's okay. This is what you have to tell to the interviewer, that this is my brute force approach. So in case you want to try out the problem, the link will be in the description, and this is
Talk to me, boy. I wanna rock your body, walk away. Talk to me, boy. Vector int visited nums dot size bracket comma yeah. For loop int I one less than num size I plus plus. Brother, am I blind or I actually have no mistake?
This is how the brute force solution code will look like, but this is something which is taking a lot of time. Yes, this is taking N1 into N2, and that's a lot of time. So we'll be trying to optimize this, and let's understand how the optimal solution will look like. So the optimal solution depends on both the arrays being sorted. Since they are sorted, we will be applying something as a two-pointer approach, and it's going to be very simple. What we do is we basically keep 2 pointers, one at this one and the other one at this, and now we will be taking the intersection of both. So tell me something. If this one, like this is the first case, is not equivalent to this two, can I definitely say that? We do not have any occurrence of one. Can I definitely say that? I can. So I'll be like, there's no occurrence of one. Please move, please. And then I'm like, at two and at two. Like they're equal. Oh, there is an occurrence. There is an occurrence. So I'll be like, let's take two. And if there is an occurrence, can I say this two is for this two? Right? So I'll move both. Because they matched. They matched. Let them put into a relationship and let's move. Okay. Now we have two. I'm like three. Okay, for this two, it's lesser than three. So I definitely cannot have a partner for two. So I'll be like, no relation. Let's move. Now this three is a partner of this three. So let's take three. Let's try to move both. We have tried to move both now. And now this three says, okay, fine, I can still have a partner. So again, take three and move. Now this four says, I'm lesser than five. So I definitely cannot have a partner. Now the five says, I'm equivalent to you. So five will be a partner. Let's move now both. So whenever they match, move both. If they do not match, then just move.
So what is the problem statement say?
So I take
Intersection of two sorted arrays.
I don't know of partners. Remember this?
The term sorted is very important if you want to go for the optimal solution. So keep that in mind. Okay, what do you mean by intersection? The element that is present in both array. Remember this. Present in both. Present in both. So if I have to write the intersection of A and B sorted arrays, so if I see 1, I don't see a 1 here, so I'll not take it. If I see 2, I actually see a 2 over here.
I've taken, let's, so we like the intersection of and how the optimal solution will look like. So the optimal solution depends on both the arrays being sorted. Since they are sorted, we will be applying something as a two-pointer approach. And it's going to be very simple. What we do is, we basically keep 2 pointers. One at this one and the other one at this. And now we will be taking the intersection of both. So tell me something. If this one, like this is the first case, is not equivalent to this 2, can I definitely say that? We do not have any occurrence of 1. Can I definitely say that? I can. So I'll be like, there's no occurrence of 1. Please move it, please. And then I'm like, at 2 and at 2. I'm like, they're equal. Oh, there is an occurrence. There is an occurrence. So I'll be like, let's take 2. And if there is an occurrence, can I say this 2 is for this 2? Right? So I'll move both. Because they matched. Let them put into a relationship and let's move. Okay, now we have 2. I'm like 3. Okay, for this 2, it's lesser than 3. So I definitely cannot have a partner for 2. So I'll be like, not an issue. Let's move. Now this 3 is a partner of this 3. So let's take 3. Let's try to move both. We have tried to move both now. And now this 3 says, okay, fine, I can still have a partner. So again, take 3 and move. Now this 4 says, I'm lesser than 5. So I definitely cannot have a partner. Now the 5 says, I'm equivalent to you. So 5 will be a partner. Let's move now both. So whenever they match, move both. If they do not match, then just move. Next, 6, equivalent to 6. So I take 6 and I post. I run out of partners. Remember this? I've taken 6 and the moment I move both, let's try to move both. We have tried to move both now. And now this 3 says, okay, fine, I can still have a partner. So again, take 3 and move. Now this 4 says, I'm lesser than 5. So I definitely cannot have a partner. Now the 5 says, I'm equivalent to you. So 5 will be a partner. Let's move now both. So whenever they match, move both. If they do not match, then just move. Next, 6, equivalent to 6. So I take 6 and I post. I run out of partners. Remember this? I've taken 6 and the moment I move both, this I exceeds. So there's no one else to be compared with. There's no one else. So there's no one else who will be partnered with. So it's over. So once you have done both the pointers, this is how it will look like. And this will be your answer. Quite simple. So if I have to code this, the problem link will again be in the description. It's going to be very simple. I is going to be 0. J is going to be 0. And I'll be keeping a vector int answer. And at the end of the day, I will definitely be returning it. And I know one thing for sure. I'll be iterating in both of them. So I lesser than n and then j lesser than n. Quite simple. And now I know one thing. If this particular a of I is lesser than b of j, for example, obviously, if a is smaller, it doesn't have a partner. Please move. You don't have a partner. Please move. And I'm like, what if It's the other way. The other way means, what if B is smaller? Then definitely the B guy cannot have a partner. Sorry, please move. But if it's not the case, they're equal. You guys can go into a relationship, isn't it? So I'll be like, okay, please go. And both of them are same, so it doesn't matter which one you insert. And both of them can go ahead because you guys are committed. Now you cannot have dual relationship. Go ahead and let the other ones find theirs. Fine, I'll go ahead. Once this is done, the answer will be stored here. That's it. So if I'll just go ahead and submit it. So if I submit it, I will see that this is running, and absolutely fine. Yeah. So what will be the time complexity? Can I see? The moment I run out of partners for someone, that's when I end. But what can be the worst case when you like keep on going, keep on going? Since I'm moving I, I'm moving J. So the worst case can be once this executes, the other time this executes, the other time this, the other time this. So if you're like I, J, I, J, I, J, I, J, I, J, I, J. So if you're moving like one by one, it's more like once you're here, this moves. The next step, 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 this moves. So moving one by one by one. And this one has an N1 length, this one has an N2 length. Can I say the time complexity? It will be N1 plus N2. That is in the worst case. That is in the worst case. Can I say the space complexity? Are we using any extra space? The answer to that is I don't think so. We're not using any extra space. So the optimal solution has a time complexity and space complexity of this that is seen on the screen. So I can say that I've successfully solved the optimal solution of intersection of two sorted arrays. So I can go back into the sheet and I can say this is done as well. So with this, we covered up 9 problems from the easy section of the arrays. I know this was a long video and I hope you enjoyed every bit of it. So please, do
चोद क्या था भाई ये ज्यादा नहीं था उसके लिए This is not for sorted array. Later I'll do that. इसका brute force solution would be hmm. Slow आएगा I think. हैं.
So what does the problem? So this is another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course on DS Algo. Why do I say that? Because in this course, I'll be covering over 455 modules and we will be solving more than 400 plus problems. You can go across the internet, buy any of the paid courses on DS Algo. None of them will be covering DS Algo in such depth. So once you complete this particular course, you can actually clear any of the DS Algo rounds in any of the companies in any part of the world. So till now, we have covered till step 3.1 this particular problem. In this video, I will be covering all these 5 problems. In case you want a solution for a particular problem, the timestamps will be there. You can switch between problems if you want to do that. So without waiting, let's get started with the first problem, that is finding missing number in an array. So what does the problem state? The problem states you'll be given an n and you'll be given n minus 1 numbers. Okay. So these n minus 1 numbers will be containing numbers between 1 to n. So if you see 1 is there, 2 is there, 4 is there, 5 is there. Who is not there? Yes, 3 is not there. So your answer
No repetition.
answer will be 3 because 3 is not here. Since 3 is not here, the answer will be 3. So you have to find the number that is not there between 1 to n. In this case, 1 to 5. So 1, 2, 3, 4, 5. 1 was there, 2 was there, 4 was there, 5 was there, 3 was not there. So this is what the problem states. So if this question comes up in an interview, the first solution that you will be giving is definitely the brute force solution because you will never jump to the optimal solution because it's you who has to drive the interview. So what is the brute force solution? The brute force will be like, okay, I know the numbers will be from 1 to n. So I'll be like, cool. Let's take 1. Does 1 exist? Yes. So 1 is not my answer. Let's take 2. Does 2 exist? Yes. So 2 is not my answer. Let's take 3. Does 3 exist? No. So 3 is my answer. So what I will do is, I will take every number and I'll check in the array if it exists or not by linear search. And if it doesn't, then that's my answer. So that will be the initial brute force solution. How will the code look like? Let's check it out. So basically you say for, I know the numbers will be from I till n. That's something which I know for sure. Now let's do a linear search. For int j equal to 0, j lesser than, I know the size is n minus 1. So j lesser than n minus 1 and j plus plus. What I do is, I know the number is I. If array of j is, like we can just scroll through and figure it out if it does exist. So flag can be set as maybe 0. And if this is equal to I can say that yes, it does exist and we can break out. Quite simple. And this can be inside the if. And outside this for, from initial brute force solution. How will the code look like? Let's check it out. So basically you say for, I know the numbers will be from I till n. That's something which I know for sure. Now let's do a linear search. For int j equal to 0, j lesser than, I know the size is n minus 1. So j lesser than n minus 1 and j plus plus. What I do is, I know the number is I. If array of j is, like we can just scroll through and figure it out if it does exist. So flag can be set as maybe 0. And if this is equal to I can say that yes, it does exist and we can break out. Quite simple. And this can be inside the if. And outside this for, I can say if flag is still 0, which means this number was not there, because if this number would have been there at any moment, flag would have turned to 1. So if the number is not there, I know my answer. Like you can directly go ahead and say, I know my answer is I. Quite simple. You pick up 1, you check entirely, does it exist? You pick up 2, you check entirely, does it exist? You pick up 3, you check entirely, does it exist or not? So what will be the time complexity? 2 loops, 1 for n, the other near about n. So can I say 2 loops? Means the time complexity, the worst case, if I
Hmm. Great. I J0 nums. I0 है. Oh my bad. Okay. Let's see the optimals.
If the last number is not found and this gets executed at the last, assume 5 was not here. Assume 5 was not here and 3 was here. In this case, the loop will entirely run from 1 to 5. And when it comes to 5, it will not find 5. So the worst case will be this loop runs entirely and this loop keeps on running every time. Like that's nearly the worst case. Not exactly the worst case because a lot of times you find here, so the loop will break. So I can say the worst case, which is again very impractical. The worst case is kind of n square. Again, it's a hypothetical scenario because when you're looking for 1, you found 1 here and you broke out. When you are looking for 2, you found 2 here, you broke out. So this will never go till the end. So it's a hypothetical scenario. Got it? That's how you explain to the interview. And the space complexity used is big of 1. That's my brute force solution. This is how you should explain to the interview so that your thought process, your concept clarity is clearly visible to the interview. So when you tell the brute force solution to the interview, they'll definitely not be happy and they'll ask you to optimize it. That's when you go across and give him the better solution, not the optimal one. And you'll say, maybe I can use hashing. And how will you use hashing? So you know the numbers are between 1 to 5. And if you want to hash 5 somewhere, you need that fifth index. So if you need the fifth index, you will have to declare an array of size 6 as your hash array. So in the hash array, I will declare the array of size 6. I go ahead and declare the array of size 6. If you declare the array, hash array of size 6, then you get the fifth index, which will be your last index. Now what you will do is, once you declare the hash array, you'll start iterating 1. You'll go and mark 1. And rest everyone initially would be 0. Then you'll go to 2, mark it as 1. Then you'll go to 4, you'll mark it as 1. Then you'll go to 5, you'll mark it as 1. Done. Once you have marked everything as 1, you will reiterate from 1 to 5. You will iterate from 1 to 5 in the hash array. And you figure out who is not marked. So when you go, this is marked, this is marked. Oh wait, this is not marked. So 3 is your number. So 3 is your answer. So we can easily solve it using hashing as well. Let's look at the code. The code is going to be super simple. I'll be like, okay, hash of size n plus 1 and everything will be initially 0. And then we will be going across and saying, let's go across the array. And I know for that array element, I have to mark. Once I've done this, I know the numbers are from 1 to n. So I'll go from 1 to n and I'll say, if my hash of i is equal to 0, that is going to be my answer. That is going to be my answer. And this will be your answer whenever you find out the hash I to be 0. So what will be the time complexity? Let's analyze. A single big O of n loop and another big O of n loop. So it's a time complexity of 2n at the worst case. So if I ask you about the space complexity, that's definitely big O of n because we are using a hash array in order to hash all the elements so that we can remember which one was not present. Got it? So that will be your better solution. So when the interview again here's the better solution, it'll be like, okay, we didn't work on the time complexity, but now I'm not impressed with the space. Can we optimize the space complexity or not? Now this is when you'll come up with the optimal solution. Now remember one thing, this problem can have 2 optimal solutions. One is the sum, the other one is the XOR. And I'll tell you both and I'll tell you the minor difference between them. So something I know for sure is if n is 5, the numbers in them will be 1, 2, 3, 4, 5. And if I sum them up, I know in order to sum up the first n natural numbers, the formula goes as n into n plus 1 by 2. Very basic maths. So it's like 5 into 6 by 2. So the summation is 15. You can also sum it up, you will get 15. So that is the summation of the first n natural numbers. Now I will go across and I will take an S2 and I'll start iterating. Okay, 1. Maybe I'll just erase this so that I can reiterate. So I'll go to 1, like add up 1. So 1 added.
Then I'll go to 2, add up 2. So this will become 3. Then I'll go to 4, add up 4. That will become 7. Then I'll go to 5, add up 5. So I'll be like, okay, 12. So we have 12. Now, if one number is missing, then can I say 15 and 12? The difference will be that one number because you summed up every one. Whom did you not sum up? The one number that is missing. So if you take the summation of the first n and summation of one missing, so what will be a missing number? Yes, your missing number will be sum minus S2. Your missing number will be sum minus S2. That's very simple. Use a summation to have a formula of n into n plus 1 by 2. And then you say for I equal, like you can keep S2 equal to 0, I equal to 0 to n, and you can keep S2 plus equal to array of I. And your number will be quite simple. Summation minus S2 will be your number. Very, very simple. So this is how the summation works. What will be the time complexity? We're just running a single loop in order to summate all the elements. This is a straightaway formula. So the time complexity is big of n, and the space complexity is big of 1. Is it better like this? This is the best we can do. But we can still do better. That is solve. You might ask me, but Striver, how can you do a better with solve? That's when I'll explain this. Let's understand. So coming to the second optimal solution that I was talking about, that involves XOR. Now a lot of people might not be knowing XOR. Do not worry. I'll be covering XOR in depth. When I cover the bit manipulation part. But as of now, just understand one concept of XOR. That is, if you XOR same numbers, the XOR of that is always 0. What do I mean by same numbers? If you say 2 XOR 2, it will be 0. If you say 5 XOR 5, it will be 0. If you say 2 XOR 2, XOR 5 XOR 5, that will also be 0. Why? This in itself is 0. This in itself is 0. 0 XOR 0 will also be 0. Alright. If you say something like 2 XOR 2 XOR 2 XOR 2, then it will be like 0 XOR 0, that will be 0. If I say 2 XOR 2 XOR 2 XOR 2 XOR 2, it will be like this is 0, this is 0, XOR with 2. So this is 0, XOR with 2. And 0 XOR with any number is the number itself. Is the number itself. This is the thing that you have to remember. Nothing else. That's the thing that you have to remember. So coming to the most optimal solution. So I hope you understood. Till now. N is 5. So when I say n is 5, I know n natural numbers. It's like 1, 2, 3, 4, 5. I know 5 natural numbers are these. If I write this, will it be like 1, 2, 4, 5? Can you somehow relate this to XOR? You can. You'll say, Striver, what I can say is, they are same. So if I try to do a XOR, each of them will be 0. And only this guy will be left. Because I know 0 XOR any number is any number. I'm like, yeah, that's true. So what I will do is, I'm like, okay, fine. Let's do one thing. Let's take a variable XOR 1. And in that, do this. And remember when you do this, there will be numbers stored. So we have understood, right? Okay, XOR 1 is done. What about XOR 2? I will take XOR 2 and I'll be like, iterate through the array. Let's iterate through the array. So if I iterate through the array, 1 is at first, then there's 2, then there's 4, then there's 5. So XOR 2 is computed. This will be a certain number which will be computed. But in the back of the number, the computer knows that this is what it means mathematically. I know a number will be generated, but mathematically it still means this. So what will happen is, if you do a XOR of 1, XOR of 2, what will happen? Yes. This and this will be together, which will be 0. 2 and
2 will be together, which will be 0. Then 3 and there's no 1 with 3, so 3 will be alone. 4 and 4 will be 0, and there's 5, which will again be 0. 5 and 5. So this 3 is alone. So apparently 0 or 3 will be 3. So you get the number 3 because they will cut off. They will cut off each other. They will cut off each other, and the only number remaining will be 3. Quite simple. So in order to implement this, how do you write the code? We'll be like, let's take zor1 equal to 0, and then we start from 1, and we go until n, and we go like zor1 equal to zor1. And I know the array size is like we need zor2, so zor2 equal to 0. The array size goes on till n minus 1. Well, this will be n minus 1, and I know zor2 will be zor2 zor array of quite simple. So apparently zor1 is computed, zor2 is computed. So the answer is zor1 zor of zor2. This will be your missing number. Can I say this together, which will be 0? Iterate through the array. So if I iterate through the array, 1 is at first, then there's 2, then there's 4, then there's 5. So zor2 is computed. This will be a certain number which will be computed, but in the back of the number, the computer knows that this is what it means mathematically. I know a number will be generated, but mathematically it still means this. So what will happen is, if you do a zor of 1, zor of 2, what will happen? Yes. This and this will be together, which will be 0. 2 and 2 will be together, which will be 0. Then 3 and there's no 1 with 3, so 3 will be alone. 4 and 4 will be 0, and there's 5, which will again be 0. 5 and 5. So this 3 is alone. So apparently 0 or 3 will be 3. So you get the number 3 because they will cut off. They will cut off each other. They will cut off each other, and the only number remaining will be 3. Quite simple. So in order to implement this, how do you write the code? We'll be like, let's take zor1 equal to 0, and then we start from 1, and we go until n, and we go like zor1 equal to zor1. And I know the array size is like we need zor2, so zor2 equal to 0. The array size goes on till n minus 1. Well, this will be n minus 1, and I know zor2 will be zor2 zor array of 5. Quite simple. So apparently zor1 is computed, zor2 is computed. So the answer is zor1 zor of zor2. This will be your missing number. Can I say this will be your missing number? I can, and that's what you can easily return. Fine. We have solved the problem where we have returned the answer. Now the question comes up, but Striver, we are using 2 for loops, and the complexity is 2n. How is this better than this one? I'm like, I can still do it. I can still do something. Okay, let's erase this loop. I'm like, no, I will not run an extra loop. I will not run an extra loop in order to compute that. I will try to put the zor on over here. So this loop is running like, if n is 5, this loop is running from 0 to 3. Can I say this? This loop is running from 0 to 3. Why? Because the indexing is 0, 1, 2, 3. So the loop is running from 0 to 3. So if I write something like this, zor1 equal to zor1 zor I plus 1, what will happen? The loop that is running from 0 to 3 will end up zoring 1 because instead of 0, I took I plus 1. So it's like 1, zor2, zor3, zor4. Because 0 to 3 means 1 more. So apparently this will mean I'm running from 1 to 4 because I did a I plus 1. So I've zored everything in place for zor1. But if you remember, zor1 was taking every 1 till 5. So 5, the n is not zored. So the end of the day, you can say, after the for loop, zor1 will have to zor with n as well because it did zor till 4, it requires n. Once you've done this, you can do this. So now the big O of 2n boils down to big O of n. And that's how you explain it to the interviewer because this will tell him about your thought process, about your thinking ability. Got it? Done? Now, if I have 2, which one is better? Apparently, this one is slightly better. Why? Imagine n is given as 10 to the power 5 and summation is doing n into n plus 1, which means somewhere like 10 to the power 5 into 10 to the power 5 plus 1 divided by 2, which is nearly 10 to the power 10. Nearly. And this cannot be stored in an integer. It will overflow. So you need a bigger data type, something like a long. And if you take a bigger data type, I'm not saying it is going to take a massive space. Slight more memory will be required. That's why this is better. Why? I will tell you. When we do zor, the zor never exceeds the largest number. So at max, the zor will be 10 to the power 5. It will never exceed. Thereby, the time complexity is big of n. But we're using integers. We're not using longs. It's slightly better. Got it? So this is how you drive the interviewer from the brute to the better to the 2 optimals, and you tell him everything that you know. And trust me, this is where the interviewer gets impressed. That's why I always prefer this method. The interviewer knows that you know the optimal, but when you show all the facets of your thought process, he knows, you know brute, you know hashing, you know the sum concept, you know the long, you know the zor one loop, you know why zor is better, you know everything. That's when he says, let's hire him. So coming back to the code editor, you have the code editor, the problem link will be in the description. I've written the same code. And this time what I'll do is, I'll just say zor1, as I said, zor1, zor, capital N. And I've taken the size of this. And now I will go ahead and try to submit this and see if it is running fine or not. It is, and all the test cases do pass. So I can go back to the sheet, we can mark it, because this is done. And let's come to the next question, which is maximum consecutive ones. So what does the problem state? It's very simple. Maximum consecutive ones. You will be given an array of 0 and 1s. So if I have to look at the consecutiveness of ones, so there are 2 ones here, there are 3 ones here, and there are 2 ones here. So consecutive ones are these ones. So can I say the maximum consecutive ones is 3, and 4, it requires n. Once this one is like big 5. Ask me, that's when he says fine or not. Yes, and
XOR 1 is 0, XOR 0. Hmm.